Okay. So 3, 5, number what now?
12.
12. Okay, cosine xy equals 1 sine. Okay. So you obviously can't, hopefully obviously can't solve this for y. Right? You guys see that? You'd have to do inverse cosine, and all of a sudden this would be like double stuck. There's no way to solve for y. You really can't solve for x. Yeah, okay. So of course, what method do you have to use?
Implicit.
Implicit. I like it. All right, so how does that work? What do I have to do on this side? What's kind of the, I've got cosine of something, right? Okay, so that's the very first way you look at anything you have to take the derivative of. It's fundamentally cosine of stuff. What's the derivative of cosine of stuff? Negative sine of stuff. So you're taking care of the derivative of the basic function that it is. What then do you have to do in addition? Times derivative of the inside. And to make it easy on myself, I'm not going to do that yet. I'm just going to tell myself I have to do it. Right? Do you understand? So this is me applying a chain rule without actually doing the derivative part yet, just so I'm not trying to do too much shit at once, because that's really easy to do. You get too much stuff, it gets all over. This side's not going to be quite as bad, right? Derivative of 1? 0. You're assigned something? Yeah, derivative of 1, which is 1. Okay. So now I have to, is this cool? So now I look through and I say, okay, I still have to do this. Everything else is basically done, you're just waiting. That's the only part that I have still to do. So negative sine of xy. Go ahead and take a second and do this. What rule would that be? Yeah, this would be product rule. See, so it's so much math is about not letting too much in your brain at once. Right now, I don't give a shit about these. They're just sitting there. I don't care about them. There's no reason they should be in my head. All I gotta look at is xy. Okay, it's relatively not bad. It's okay. What's the derivative of x? 1 times y plus x. And what's the derivative of y?
1.
Holy shit, okay. Unfortunately, now I'm done with calculus. All my calculus is done. The problem becomes an algebra problem. Can somebody identify for me the variables in this problem right now? Okay, x and y and y prime. I love it. Those are 3 different variables. And which one are we trying to solve for right now? Y prime. So it's a total algebra problem now, which should be a relief, but unfortunately for some of us, I think it's not necessarily as big of a relief as it should be. I'm not trying to say anything bad, just saying it seems to be. So what do I need to do to work in the direction of getting y prime by itself? Where's my y prime stuff? Are they free to move around? Right? Because don't I want to get them all together? So if they're not free to move around, my first thing is to make them free. Free them. Right? So which one's not free to move around? He's cool. This little thing can move around all over. This guy's stuck inside of here. So let me go ahead and distribute. So I get negative plus, well, so negative xy prime sine xy. And now which piece is in the wrong place? Which piece needs to go with something else. No. Are my y primes together yet? Yeah, right, so let me move this over. You guys see that? I mean, that's all it is. How do you solve the algebra problem for x? How do you get it solved for x? Don't you distribute and then get all your x stuff on one side? So then you can divide by whatever the shit's in front of it. Okay, same damn thing. Same. Get all my y prime stuff on one side. Now, those aren't like terms, but I don't care. How many y primes are up there?
2.
1. There's one y prime up there. It's just been distributed, correct? It's only undistributed.
X, y, plus cosine.
All right, and then you just divide by this stuff. Right? So it's not, this is a grand conjunction of a lot of things. We got just about every rule just had. We had chain rule, we had product rule, no quotient rule, thankfully. But the thing that's still new to us is this, you know, with the x's and y's kind of intermingling. But again, how would you do this derivative? If you had to do this derivative, what would you do?
Start X. Or no, start 12.
Yeah, product rule, right? First thing I would do, right? Derivative of x is
Or
1 times this. Are you guys with me? Plus x times the derivative of this, right? And then I would keep going, correct? What if it was this? I have to do this derivative. Would I do anything fundamentally different? Isn't it still, it's still, derivative of x is 1. X times the derivative of this, and then I would keep going, yes? Yes? Yeah. I really want you to see what the shit I'm doing right now. So, what could I put here? Did it matter really what I put here? Did it really change the first step at all? No! So what if I just say anything I want? Anything I want. Y plus xy prime. Y plus xy prime. It just captures what you would do if you knew what the shit y was. That's implicit at the heart of it. That's what it is. You don't know what y is, but you know it's something. It doesn't matter what it is. You would do the same thing. I really, really want you guys to get that. That's all it is. Nothing magic. You don't have to guess about when to put y prime. I always get students that are like, let me put a y prime here. Because he just puts it somewhere. So you can put it somewhere. Yeah. No. No? Yes? Maybe? Sucks? Stop or tap? Okay. It's only going to be a couple problems, so I'm not going to worry about it? No. It's bad. It's a bad thought. Anything else? Today's wide open, of course. We got the practice test you can pull from. You got your quizzes you can pull from.
3.5, 37.
Oh yeah, this is awesome. Okay, beautiful. This is the kind of question I expect because we didn't talk about second derivatives through implicit. This is a lot of fun. I am going to do, because I only think I signed one of those, if I remember correctly. So I am not going to do that one. Yeah, too bad. I'm going to do, I don't know, any of the other ones, 35, 36, or 38. I'll let somebody pick if you want. Page 216. If nobody picks, I'll just pick one.
37.
37. That's the one. That's the one you asked me. Isn't that the one you asked me?
Yeah.
That's the one I signed, right?
Exactly.
All right, I'm gonna pick one. I don't know. let's do 38. Should be the grossest. Well, 38 was too easy. Oh, that's about as easy. Okay. 38 went. All right. So let's first find y prime through implicit. Now notice this one we could solve for y, we're just not going to. Because it says I have to use implicit. So you guys should be relatively excited about this. This is a relatively simple implicit problem. Yes? What's the derivative of x cubed?
3x.
Holy shit. Derivative of y cubed?
Negative 3y squared. dy cubed.
Good, I like it. Derivative of 7. Then one of the big mistakes people make is they forget whatever you do to one side, you have to do to the other. So the other side shouldn't still be 7. But I always see some poor person leave the 7 there. That really messes things up. So is that pretty cool? Can I add this over and divide by this? So I'll get 3x squared over 3y squared, which is x squared over y squared. Is that? Yes. If I add this, divide by 3y squared. You guys see that? So do we now know what y prime is? Okay. Now, I have to find y double prime, correct? Do you understand what's going to happen on this side if I leave this the way it is? Quotient rule. So you have an option. You have an option. You could do what? If you don't want to do quotient rule.
Bring it up.
You could multiply by y squared. But is this quotient really that bad? Do I have anybody with a strong opinion? Do you want to simplify first, or do you want to just attack it the way it is?
Rather simplify.
Rather simplify? Okay. So let's multiply by y squared. And now let's take a derivative. So what's happening here? That's a prime, by the way, right? This is another reason why dy dx is kind of used, especially with higher level primes. It starts to look like a first prime. Anyway, isn't this a product? What's the derivative of y prime?
Y double.
Y double prime, I like it. So derivative of the first one times the second one plus the first one times the derivative of the second one. What's the derivative of y squared? 2y.
Y prime.
Y prime. And I'll do this side. Okay. Now, this is relatively easy to solve for y double prime, but I won't be done then. Because, don't we know what y prime is? All right, that's the trick with these problems. You already know y prime is, so if it shows up again in a higher level, you can just replace that. So let's solve for y double prime. So let me clean this up. Y double prime, y double prime y squared plus 2y y prime squared equals 2x. Is that cool? That's weird, but oh well. So right now, if I wanted to, let me go ahead and do this. What's y prime?
X squared over y squared.
Oh boy. And now it's just an algebra. Subtract that, you can reduce a y, divide by y squared. Yes? Not too bad after that, is that cool? So the big thing I want you to realize is, if they want you to find a higher level derivative, implicitly, this is a key piece of information for later. Because almost definitely y prime is going to show up. But what do I need to figure out the derivative? What's somebody got to tell me about the original function? What do you have to tell me to figure out the derivative somewhere? Say again?
X and y.
Good, a point. So don't I want the same idea with the second derivative? I should just have to tell somebody a point. So if I stop here, I'd have to do this first, and then no. I just want a function that's only got x and y. Give me a point. I can solve for y double prime. Is that enough to help? Who asked that question? Yes, okay. I'm gonna leave one of those for you guys. Again, if there's anything I do that doesn't make sense of why I did it or something, you gotta let me know right then. Right? Okay. And everybody's got a practice test, right? Okay. And you see, like number 5, I just got lazy, and that was like, they already made a lot of problems. Go get it. I have the answer key. I'll give to you eventually today.
Can you do a word problem like number 4 on the practice test?
Yeah. So this one, this is going to be very semantic and out here. I think I didn't even set you up to see that far. Poor little dude. Poor little people at home. I'm sorry. Weird bag. But 4 is not a word problem. But I understand. 4, I tell you, to me a word problem is one where you got to create your own equation.
Mm-hmm.
Does that make sense? Here, I give you an equation. So it's a pure calculus problem. And I want you guys to realize that. So when you see this, you're not having a word problem spasm, right? Let's say less than, no, okay. Hours, and this is in miles. So I ask a lot of questions about velocity, acceleration, position. This, of course, is the position function. How do I create? I didn't give you the velocity function. How do you find it? Derivative. So velocity is the derivative, which will be
3
Plus 16t.
light. And again, if you need to, you could say let x equal t. If you make your t's like that, and they look like pluses. In the middle of a problem, you could replace variables because they're dummy variables. Who cares? So if you need to, you can do that. And I might as well figure out what the acceleration is, which is the derivative of velocity, which will be all right. I like it. Did I tell you what the next derivative was? Anybody? Did I say that before? There's one more derivative on top of this that actually has a physical a name.
The jerk.
The jerk. There you go. I did say.
Which was like, what was it? What was the measure? Like
The change in acceleration. So if you step on the gas pedal and your car goes, I don't know about that. Maybe. Maybe I don't know. That was mine, and that's. Couldn't think of a better. I mean, jerk is perfect for that. So here we go. Not a smooth acceleration. That means it's jerky movement, right? Okay. Now you can answer. Now it's just a bunch of plug and chug. I want you to realize that this is a calculus question followed up by plug and chug shit, right? So A is easy. What do I? Yeah, right. Now I just plug 3 into the appropriate equation. It's all about picking the right equation. Yes. B, plug 7 in for velocity. C, where am I going to plug 4 for C?
The original.
The original. This, the more interesting questions are E, and I kind of give the game away, at what time the train stops. So what would I do to figure that out?
That's when the velocity function equals 0.
Yes! What happens when you stop? Your velocity is 0. So set this equal to 0, solve for t. Not surprisingly, what's one answer when you set this equal to 0? Isn't it 0? Because at 0, you want people to get on your damn train. You don't want to be going through the, everybody jump on! Yeah. Right? All right. Jump! Boom! This time, that. Huh? No, It's not good. And you have to have people sweeping the bodies. It's terrible. So what about, so E is not too horrible. Once you realize they basically tell you, train stops, velocity 0, solve for T. Part F is the most interesting. How fast the train is going a half an hour before it gets back to where it started. Ooh, I love that. Ooh, I love that question. Well, before you figure out what half an hour before it gets back, you have to first figure out when it gets back. So when does it get back?
8 hours.
And how do you know?
Because T cannot be greater than 8.
I don't care. It doesn't mean it got back. It could have just broke down somewhere. How do you know it got back?
Velocity is at 0. The velocity is at 0.
I don't know.
Maybe it broke down though.
Oh, true.
Wouldn't it be when S of T is 0?
Yes, because what is S of T to begin with? What is S at 0? What is S at 0?
Where it started.
Where it starts. And what's S at 0?
0.
0. Right? Because position represents how far away from the station it is. Right? So when is it 0 again is the question. Right? Starts at 0, goes away, comes back. And you can pretty much, please tell me somebody can just see. Right? When is this 0 again? Well, we can factor it. There's our 0 and there's our T is 8. But don't just say 8 out of nowhere. So what's half an hour before this?
7.5.
7.5 hours. And I want to know how fast it's going, so what do I do with 7.5?
Plug it into the velocity.
Plug it in. Yes, you see. So this is not difficult. You just have to stop and think logically for a second about, okay, the question, what does it mean physically, and what does it mean mathematically, right? But it's not anywhere near like section 3.9 questions, for example. Yes, related rates. Yes.
We're gonna have a related rates problem on.
Is everybody cool with that before? Is that right? Obviously, I got everything else worked out on the answer key, but that was the idea behind that one. Good.
Are we gonna have a related rates problem on the test where we have to create our own equation?
No. I think I told you I'm going to go easy on you, right? In fact, I didn't even say that 3.9 homework is due, but I will have a very basic related rates question. And when I say that, I'm going to be very specific. Where is that? Here. I felt it. There it is. Remember this related rates worksheet that we didn't really finish? But like number 2, right? Where I gave you, I wouldn't even say it's going to be that bad. So what I'm going to do, what I did last semester also, is I'm going to have a very basic related rates question on this test. And on the next test, I'm going to have a more complicated question. Yeah. At that point, you should have finished the homework and all that kind of stuff. Yeah.
If you factor out a T squared, why is it 8 minus T? Would it be 8 minus 1?
This is T cubed.
No, on the term inside the parentheses.
No, okay. I turned it around also. So if I stay in the same order, why did I take a negative out? Doesn't matter. T squared comes out of negative T cubed. That's negative T. T squared comes out of 8. Yeah. I didn't mean to take a negative out, but I could have. Then it would have been bam. It would have been like that. Bam. Today is a little bit dependent on you. Nobody's really going to ask questions on my ask my own questions.
Right.
Yes.
3.567.
Where are you? There you are. 67? Oh yeah, this is awesome. This is one that I did have a couple people ask me about in office hours before, but if nobody asked me about this one, I'd be upset and worried, because this one's weird. So, there's a word called orthogonal. So you can have a curve and you can have another curve, and they might meet and make a 90-degree angle. So we call those curves orthogonal at their point of intersection. So it's just a grander name for perpendicular, right? So that's what orthogonal means. So what their claim is that every function that looks like this and every function that looks like this, everywhere they meet, they're orthogonal. Can anybody tell me what shape this is?
Circle.
No?
Oh.
Ellipse, good, because it's not symmetric with the x and y. Right? Okay, I like it. So that would be elliptical. And this, of course, is just parabolic. So you have an ellipse, and you have a parabola. If you give them the right curvature, you can imagine maybe they do meet at 90-degree angles, right? Okay. Where do you go? Blah, 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 blah. Okay, so tangent lines have to be perpendicular where they meet, right? That's from the first sentence. Two curves are orthogonal if their tangent lines are perpendicular wherever the functions intersect, correct? So one level of this is, where the shit do these two things intersect? Isn't that a part of this? I need to know their points of intersection. And then secondly, I need to see what their tangent lines are, which means what I have to do?
Take the derivative.
Take derivatives. So there's two main things I've got to do in this problem. So derivatives, so let's see, points of intersection and derivatives. So I have a suggestion as to how to figure out where they intersect.
Substitution?
Yes, totally. Systems of equations. How do you solve a system of equations? Eliminations or substitution? Right? I'd much rather do substitution here. Is that pretty cool now? So they will intersect when y is this and this is k. When those are both true, they'll intersect. So assume they're both true. So how can I rewrite this then? Assuming that this is true.
Square equals 2 squared.
Now this is the kind of problem students sort of skip and hopefully don't realize it was assigned. I remember one semester somebody said, I think a friend of mine said that he did that once and you didn't catch it, so I'm going to do that. I'm like, I'm going to look at your homework extra hard, all right? That was a really dumb thing to say. Because trust me, when I was a student, I did that sometimes on purpose. Because my teacher was a little, yeah. And he didn't notice that there were some problems I skipped over. I understand. But, yeah, I mean, these problems, you've got to play with them a little bit. You have to really read what they're saying and what does it mean calculus-wise. Tangent lines, derivatives, point of intersection, substitution, right? It's just like system of equations. And then you start doing it, you're like, I don't know. When I first look at it, I don't know what the answer's going to look like. Shit. What do I do from here? No. No derivatives here, right? This is points of intersection. This is not a calculus idea. All right, well, one thing I could do, right, is just do this, yes. All right, just do that. Did anyone notice what form this, can you factor to solve for x? What am I trying to, am I not trying to figure out x, y? Isn't the point of this to figure out all the points where they intersect, right? So here I'm trying to solve for x because I got rid of y for a minute. Because if I can figure out x, I can then figure out y. Now listen, is this straightforward? No. But on another level, yes. It really can I solve this by factoring? Why can I? Let me ask you like this. Why can I not solve this by factoring? Can't I take an x squared out? It gives a shit because that's not
Zero.
0. I don't give a shit. You can factor the damn thing.
Root both sides, maybe?
No, because the root can't go across addition. So let me build up to this. Okay. How do you solve a problem like three? Now, how do you solve this? This would be huge. You ready? You guys will never get this. How do you solve this? All right, factor that for me. Oh, okay. How do you solve this?
You could use box method to find the roots.
No. You can't factor this because you tell me factors of 4 that add to be -1. Do it. Stop trying. There's an. So how do you solve this? Quadratic formula, right? Yes, yes. And if you can't factor quadratic, you use quadratic formula, right? Okay. And real quick, to do quadratic, negative b, so it'll be +1 plus or minus square root of b squared minus 4ac all over 2a, blah, blah. Who gives a shit, right? Okay. Now, how do you solve this? Is that quadratic? Yes, it is. All day long it's quadratic. It's in quadratic in form because this is half of that. If I could factor this, wouldn't this be x squared? Wouldn't it be x squared, and then that makes the middle term x squared, right? As long as the middle term's power is half of this guy, it's quadratic in form. Can I factor it? No, same problem as before, right? So I use this, it's going to look exactly the same, except what's it going to be equal to now? This is equal to x. This will be equal to x squared. Oh, you guys are so excited. You guys have to know this stuff about quadratic in form. So that's, now watch, okay. Let me write this like this. Descending order in power. Subtract the k over. Can somebody tell me what a is? Just like up here, a was 1, b is -1, c is 4. What's a? 2c squared. What's b? 1. What's c? Negative k. Throw in freaking quadratic formula. Now listen, guys. If you did this and got somewhere and you're like, I don't know what shit to do with that, I understand, because unfortunately it is something we don't talk about much. But all you need to do is be quadratic in form. Because really, what you're doing is, let me see if this looks more familiar. What if you let u equal x squared? Isn't u squared x to the 4th then? So isn't this u squared minus u plus 4 equals 0? Doesn't it look exactly like that? When can you do this? When that power is half of that power. So when can you use quadratic? When that power is half of that power, because you can make it look like quadratic. Alright, so that is as far as it's going to take you there. You got to keep going. Ooh, baby. Once you figure out, now listen, is that going to be pretty? Not at first. But if I remember correctly, it simplifies a bit. The minute you know what x is, how do you get what y is? Y is cx squared. So you just got to do c times whatever you got squared. And then, derivatives should be the easy part of this, to be honest, right? You have to do some implicit, but I mean, it's... Alright, so hopefully, maybe that's enough to get started on that problem if you weren't really sure what to do with that. Did anybody get like up to this point or? No? Did anybody get up to this point? Yeah, okay. I understand. You guys look at those problems and you're like, no, thank you, Jeff. But part of it is brute force. It says tangent lines, derivative. All right, cool, let me do that. It's easy to look over points of intersection, but all right, points of intersection, we know how to find where two things intersect. It's a system of equations. Okay. All right, guys, I like it. So very happy that question came up because that's definitely a weird problem. I don't give you these problems and go, you could do these, just, take like 10 minutes and do all this. It's not the point. The point is, some of these are basic and some of these are really challenging. Do what you can, right? Get help. Okay. Anything else that has been bugging you from the homework? Or even basic shit, right? What the hell's chain rule again, Jeff? I don't know. Right? Now's the time to ask.
Can you do C from the quiz?
3. Oh yeah, that's a good one. So this should feel kind of familiar to some of the problems in the homework, especially that one that had like the parabola and the point. There were 2 lines that would go through. I was a little sneaky here. It's a bit of a trick question, but not really. There's 2 answers you can give me. I would take either one. This is the one you're talking about, right? Finding the equation line that's tangent to the curve. Okay. So the curve I give you is this. And so I want to find the tangent line to this curve that goes through I like it. All right. So anything up there make you think about doing something? What's the most obvious thing that you need to do? Take the derivative. Tangent line. I need the slope. Let's figure out the derivative. All right. And then you're like, okay, I got that. So here's the trick with this kind of question. Normally, I say find the equation of the tangent line to this curve at this point that the curve goes through. Right? And then you just have to plug that in. Do we have anything we can plug in here right now? Would I plug a 10 in? Would that mean anything? Is this point on this curve? Try it. No. And there's nothing I don't say it is. I want the tangent line to x squared minus 9x to go through the point 10, negative 6. So it could be maybe one here, or it could be one up here. And you could even draw a more detailed, really smart idea to either graph on a graph calculator, go in Desmos, just graph x squared minus 9x. How did I know it looked like this? Well, I know 0, I know 9, I know 4.5, and I know if I plug a 4.5 in here, I think I get roughly 18, negative 18 or something, I don't know. Sure. But you can be more precise. So you guys have got to be more open to graphing what the hell you're working with, right? So, it doesn't matter which point. What's this point right there? I love this question. What is that point right there?
Positive X,
I like it, X and Y. I don't like the way you said positive, because X and Y could be negative. I mean, I could have picked this point, and what would I call this point? I would call this point XY. Right? This is just a general, it's just some point. I really, come on, this is huge. This is kind of like related to a lot of little problems you've done in the homework, but I don't think they gave you one quite exactly like this. Right? And I'm an asshole, and I know a lot of them, so I'll make a weird question like this. Do I know, now look, what's the slope of this line here?
0.
What? How do you know that shit?
Because it's
Or
straight.
it's also tangent.
Based on my beautiful graph? It's a straight. Is this? Where is this point exactly? Did I put it right where it's supposed to be? I don't know. It's a guess. There's no reason that should be flat. There's zero reason that should be flat. I don't know. Okay.
Y2 minus y1 over
Yes. What's this point? This point is 10, -6, right? Now, what is either of these slopes? Either of these slopes would be the same thing. Y plus 6 over x minus 10, yes? Both slopes are the same. Now, you might say, why? What do you mean? Well, because they're based on y and x. So, of course, they're going to change based on which point I'm looking at. All right, so don't I have one expression for slope right there? Isn't that the slope at every point? And what do I want specifically? I want my slope to be y plus, is that, everybody see that? Y minus -6 over x minus 10. So if that's what I want the slope to be, and that's what the slope is everywhere, what can I do with these? They have to be equal. Can somebody help me out? What is y? We've known since the beginning what y is. Y is x squared minus 9x. I love this, and of course I would, right? Of course I would. Because I'm a weird dude. Must got dropped in my head, and I love math. Of course I love this. But what I love about this problem is there are two ways to represent slope. There's a calculus way to represent it, and there's what it must look like to satisfy what this problem wants. So what can I do with these two expressions? Set them equal to each other. They have to be equal. So I get 2x minus 9 equals, let's replace y with what it is. Good. And how do you solve that? What's the worst part about that problem?
Denominator, so bring it
So
up.
kill the denominator, right? And so the great thing about equations is 98% of the time, if you see something you don't like in an equation and you kill it, you can keep going, right? And you're allowed to kill it. Only math guys, don't tell the cop my math teacher said it was okay to kill people that were promised. I didn't say it. Anyway, that's screwed. The rest of it's algebra. What's really important there is if you don't draw the picture, you're going to miss out on this whole idea, right? We can't forget that there are two ways we can look at slope now. Derivatives, and then y2 minus y1 over x. They're both there anytime I need them. And this happens a decent amount. Okay. That's time we got. Okay. I'll give the key out in a minute. Look at 1f, for example. There is, what is it that I tell you, that I've told you many times, that you should look for first before taking derivatives?
Variables.
Simplify. Can you simplify a natural log of something to a power? Can you do anything? Right. Is there a way to rewrite natural log of x squared? 2 natural log of x, right? So can't you take that sign, bring it the shit down? You guys see that? Okay, and then it becomes easy. Right now, this is unbelievably disgusting. This is a chain rule inside of a chain rule with an exponential. Ah, what do you have against me, Jeff? And I'm like, nothing. Just bring the sign down. Shit. Right? You know I'm going to do that to you. You know it. And it's not me doing it to you. It's me checking to see, did you get the message? Was there anything else you could simplify? Any other functions you could simplify first?
D, because you have to get rid of the squared and turn it to exponential part.
Oh, okay, so just rewrite it. But I'm with you. Make the radical into 1/2 power, right? So you can do the same thing with 1a. But is there anything you can actually fundamentally algebraically change through simplification first? E. You can factor the top. Otherwise, it's a kind of a semi-gross quotient rule. If you factor the top, now, and watch this. Have you guys? All right. I'm always concerned about what you're not being told in pre-calculus. So let me show you something really, really freaking useful. The only way it would be useful to factor the top is if what was in it? X minus 4. If it doesn't have an x minus 4 in it, factoring it doesn't do shit for me. Do you guys agree with me? So let me assume it's got an x minus 4 in it. Because if it turns out that assumption's wrong, then I'll just start doing quotient rule on it, right? So if there is an x minus 4, what's this got to be? 3x. And what does this have to be? Negative 2. And how do I check? Minus 12x, minus 2x, minus 14x, check, kill, derivative. Have you guys ever seen that? Where you have a hint in a problem, it's now something factor, so you just plop it down. Much better than 3 times a is 24, factors 24. Here I've got a hint. I've got a hint. Let me write it down, and then I write down what makes that work, what makes that work, and then I check the middle term. Golden. Die. Derivative is 3. Next. Right? Right? Yes? No? Does that mean every quotient I give you can be reduced? No. But check first, obviously. Right? How do I do 1G? What form is 1G in? Is it in a form? What do I mean by form anyway? I know how to do forms like this, yes? Forms like that are the best. I know how to do forms like this. Forms like that are not the best, but they're not that bad, right? Is it in either one of these forms? No and yes, it's in both. So I can't use either of these. So does anyone remember what I can do? We replace this with y first on.
Natural log plus.
Yes, the big clue is there's an exponential that I wish wasn't there. And the only function that can kill an exponential like that, or at least move it somewhere else, is natural log. Now, some of you guys might look at that and say, that looks much worse. I think that looks infinitely better because this was impossible, and this is possible. But of course, what do you have to do now that you've introduced a function of y like this? What do you have to use?
dy dx.
Implicit, yeah. Yeah.
Why is w prime of x impossible?
Y is who to what?
Why is taking the derivative of w x impossible without doing implicit?
because this is not, well, all right, to be completely honest, there is a way to memorize a method to do it directly, but it's based on the results you get from this. So it still is dependent on this process. Does that make sense?
Yeah.
But it takes some memorization of it, and it's, I could show it to you if you wanted to.
Because that's different from the, like, it feels like 5 to the secant.
Yeah, it's not x to a constant. It's not a constant to a function of x. It's both. So is there a rule I can apply? No, because it doesn't really fall into either one. Right? They both require constants somewhere. And this one has no constants anywhere. I don't have a derivative rule for it then. So a huge deal is all about what form something is in. Right? Beyond just product for product rule, quotient for quotient rule, it's also the basic forms like x to the n, like we just said, and a to the x. And even just tangent x. Is it in the form tangent of something? Well, then we know it's derivative then. Right?
Just wanted to make sure. Quotient rule is g prime times f minus g times f prime over g.
No. So remember, did anybody remember my song for quotient rule? Top first. So as quotient rule is, if it's f over g, f prime g top first, minus f g prime over g squared.
I think the book has it in reverse, that's why. I think the book has it as g prime f and then minus.
Oh, I see. Yeah. Depending on how you write the composite. Okay. So I mean, this would be 1 over y times y prime is equal, right? And then this would be a product rule. Okay, I've got it on the key. I'll give it to you. All right, let me go ahead and give you the answer key so you can kind of look through there, find any mistakes.
Like that, hard copy of the practice.
Yeah. Anything else you want? There's 2 pages to the answer key, not surprisingly. Go through there, let me know if you see anything that's different from what you got. And just to remind you guys, please, dear Lord, if you didn't try the practice at all, don't just go. Yep. I would have done that. Right? I mean, so you're going to build false confidence. The test isn't, do you agree with this? Yeah, I do, Jeff. You know, so don't even look at the answer key if you didn't do the practice test. It will do negative help for you. to show you something. Watch this, guys. If I have x equals sine y, what is dx dy? So just to remind you, if I have y equals sine x, what is dy dx? Cosine x, right? Why is it easy? Because I'm taking the derivative of the variable that's in there, yes? So if x equals sine y, what's dx dy? Cosine y. Right? Okay, now. So I can do this semi-quickly. What if I had x minus sine y equals natural log of y? Sure, I like it. And we want to find dy dx. All right, let me just show you this semi-quickly. I would do implicit, right? So I do 1 minus cosine y times y prime equals 1 over y times y prime, right? I'm going to use it a little bit quickly. Then I would add this over, and then I would take a y prime and then divide by cosine y plus 1 over y. Yes? Okay. So that's dy dx, right? Now watch. What if, instead, I had just added sine y over? What's dx dy then? See how it's x is a function of y? What's dx dy? So what's dy over dx? Maybe? So I showed somebody this earlier. I don't show this too soon because this is a little weird in itself. But just reminds you that all these are ratios of changes in things. So if I know one ratio, how do I get the other ratio? Just flip the damn thing. Isn't that crazy? So yeah, if I have a situation where I could solve for either letter, I do it. And then I just find whichever one is easier. And then if they wanted the other one, I just flip it. It's almost too nice to believe. No? Yeah. Don't care. Okay. All right. Anything on there look strange on my answer key? And all right. I want to show you this real quick. So you guys can see like the number 3. The number 3 that we talked about with the slope was 2x minus 9. You had to do the other weird thing. Let me show you. Turn off. Yeah, it is. Okay. Weird little thing. All right. Let me not show you everybody's grades. Close that. Today's lecture brought to you by Hitachi. So, go to Desmos. Looking at this number 3, and I type in the original function, right? And then I type in either tangent line that I got. So let's do 3x minus 36. Well, get out of there, H. Get out of there, thing. Okay. So remind me, so look, is it tangent to the curve? All right, check. What was the other thing it was supposed to do? It was supposed to go through the point 10,
-6.
-6. You guys see that? It goes to the point. All right, so I mean, you're allowed to use your graphing calculator, right? Desmos is beautiful. Your graphing calculator will still work. It'll still work. You can kind of check your work. I mean, if you get an answer and you plug it in and it looks like this, does that look like a good candidate for a tangent line?
Nope.
No, so you immediately know you made a mistake somewhere, right? So it's fine to check your work. It's even fine, really, to just plug something in the calculator in the first place. You just can't let the calculator do the work for you, but I mean, just to get a feel for what the shit, like that one problem, like this problem, where you first plot the function and you look at 10, -6, and you can kind of do a rough sketching and kind of get the idea, oh, this is what they mean. There's a tangent line, there's a tangent line. You can see it then, and you're more connected to what you're doing. So there's nothing wrong with that. It's not cheating. It's only cheating if you have like subroutines and your graphic calculator and hey, I can make you do this shit. Yeah. Blarf. All right, that's why you got to show your work. Maybe? Yes? Okay, okay. Some of you guys look defeated. I'm sorry. It's going to be okay. Anything else? Or are we all done? Are we all done? I mean, that's an option. You can all just sit here looking at each other, or you want me to ask another question? Yes?
3.1, there's a bunch of problems with like ratios in that. I was confused. How are we supposed to solve them using like just the power rule? If like we don't know change what you have 3.1.
You have to simplify. So give me an example.
For number 22, like
Yeah, dude.
root x plus x.
Whenever the bottom of a division problem is a single term, you can simplify it. You can make it not division, not like long, not like big ass bar division. What do I mean by that? Well, so if I have x to the 1/2 plus 2x to the 7th over x to the 3x or something, right? Can't I do this over this plus this over this? Subtract powers, and now I got no quotient. If there was another term, I'm screwed, right? Then I need quotient rule, but the minute that's only one term, you can do it term by term, bam, 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 bam. As long as everybody gets divided by this, you're doing what it's asking you to do. Okay. So yeah, people were using product rule and quotient rule, and this is a very frustrating thing when you're taking a higher level math class or whatever, and you learn something but you're behind in homework. You cannot use something we learned in 3.2, 3.3 work in 3.1. So that's a perfect example of, yeah, and it's frustrating because the first thing you think then when you look at that is, oh, it's a quotient rule. But I'm not allowed to use quotient rule. Wait a minute. Yeah. So like when the tutors tell you to do weird things with your limits, something called L'Hopital's rule, which we haven't learned yet. Why do they say it then? Because it's the smartest way to do it. We just don't know it yet. We haven't proven it yet. We don't know enough yet to use it. Yeah. Okay, let me see. Was there anything on here that I'm surprised nobody asked about? Well, I mean, some of the problems in number 5, but I can sort of understand. Because so problem number 5 references problems from the review for chapter 3, and like, for example, 97 and 101 are, well, I would give you number 97, but I would give you the formulas, right? I'm not going to make you memorize all the geometric formulas for volume and surface area and all that. But I mean, even 97, you should be able to figure out the volume and the surface area of a cube. But still, you guys kind of with me. But number 101 is a little more involved. So that'd be an example of a related rates problem that I'm not going to go that far on this test with it. Yeah. What about number 90? Anybody try number 90? Does that make sense? They give you the volume of, what was it? The cone? Yeah. And they say find the derivative, the change of the volume with respect to the height if the radius is constant. So if I change the height, how much will the volume change is the question. But the radius is held the same. So what would that be then? dV, d what?
dH.
Yes, because I'm letting h change, not r. So it is just as easy as you would hope. So this is a constant. So what's the derivative of constant times h? What's the derivative of 5x?
Oh,
5. So what's the derivative of thing times h with respect to h? Thing. Bam, down. You see how it's with respect to height, not time. So the height is changing, the radius is not. Maybe. And then, of course, part B is the same, except the height is constant and the radius is changing, and it works the exact same way. So that's just kind of pointing out that there could be, in your future problems, where there's multivariables, but some of them are going to hold constant. Right, because what is physics and chemistry all about? What if I keep the pressure the same, but I increase the temperature? So now in my equation, if I see pressure, it won't, the derivative won't affect it, because it's a constant. Is that, yeah, and that makes sense. Physically, what if I did that shit? Let's try it. Okay, let's not do that again. Right? Sorry. I just, sorry. I've lived something close to that. Anyway. I did the math wrong, and then I said things, and then I blew out a few things. And I'm like, oh. Yeah, they were really excited about me. Oops. Okay. Anything else? I did a lot of math right, don't get me wrong. Just that one day I decided, well, let's see what happens. I do the math wrong and almost done. Oops. Alright, well, that's fine. You're all ready? Sweet. So don't forget, office hours in the Math Study Center, you got the tutoring, right? I'll be here again Wednesday, 8 o'clock. I'm in here. It's great. Of course. We'll just keep going. We'll finish up chapter 3 on Friday. Say again? As much as you want to do out of what we cover on Friday. And then, test corrections if you have to make any test corrections. So. But, as always, it'll be a rough due date because you have time until the test. So you can do as much or as little as you want to, which is the way spring break should be.
Is 13